So yeah, so I'll go with some sort of general high-level questions. The first one, I guess, is in quick one or two. Sorry. Yes. Yeah. So I will ask everybody to quickly introduce yourself, and then talk a little bit, like maybe in one or two sentences, the most interesting or challenging technical challenges that you have encountered in your career related to robotics or construction, so that then we can open up discussions after that. We can start from maybe Christian, and then go around this.
Hi. So you've heard me speak this morning. I'm Christian Moore, and I'm representing XYZ Reality, a London-based late-stage startup working in construction. And our challenges, I think, are like many people involved in robotics and localization. It's about precision and robustness. How do we reliably observe and continue to observe a construction site, both inside and outside?
Thank you. Hello, I'm Fu Zhang from University of Hong Kong. Well, for me, I think the most interesting problem is in my career was how to identify interesting research problems. I would say that. Yeah.
Hi, thanks. I'm Margarita Chli with ETH Zurich and University of Cyprus. Technical challenge on working on robotics and construction. I would say with respect to perception, our biggest challenge is the dynamicity, how quickly the scene changes. But if it counts as a technical challenge, it's also making things work in the field, right? So from theory to practice.
Hello, I'm Che. Is from Kazima Corporation in Singapore. As the private company, my challenge is very clear: how to make a profit by construction robots. Hi.
Hello everyone, I'm Dr. Daobo Zhang from Tsinghua University. I think the most challenging is maybe the material and the structure system. Because for the robots, we have to decide which material and what's the future systems. Yeah, thank you.
Okay. Thank you very much. So I'll ask the audience to start preparing questions. If you want to ask the audience based on their expertise and the challenges they mentioned. While you're preparing, I'm going to open up with one question, which is now everybody's, since last year, ChatGPT is like everywhere, right? And then the generative AI and everything. So everybody's talking about this scaling law and how AI can be used to, well, it's the next big thing. And then AI and robotics is naturally connected. So my question to you is, what do you think about this new wave of this trend in both research and especially in the industry? Do you think this new wave of AI is going to revolutionize things that you care about, especially related to this workshop on construction robotics? Do you think there is a scaling law for what this community cares about?
Okay. I'll talk first. Okay. I think it's a revolution because like the presentation we gave in the morning, we are in the second generation of civil engineering. And with the help of AI and the robots, I think we can push to the third generation. Like we can make quite new buildings, not just like this traditional use concrete, steel. That's quite traditional. I think like in the past we use woods, right? But now we mostly use concrete. Maybe in the future, which material should we choose? I think the material we choose like FRP or any other advanced materials, it should be suitable for the robots. I think that's the matters.
Okay, as AI and then some new technologies, ChatGPT, and our company is the has the potential to use that new solution to more is the used our is experience, our is the historical data and something. But as the engineering viewpoint, we need more is a high accuracy at the competence to use that as the answer is we can use as the engineering part. That's I think is one of the big issues for us.
So you're saying the engineering, in the industry, people are still having like still wait and see.
Yeah. Sure.
Okay.
Yeah.
Thank you.
Yeah, I think your question is very difficult and complex. And I'm glad two people spoke before me, so I had some time to think. Not enough. But in general, I think that, ChatGPT and AI, right? So in the same way that I would like to use it in my everyday life as an inspiration, I think it would be a great thing for construction. For example, imagining new ways of, I don't know, having a hospital instead of having it in a very rectangular manner. So architecturally, I think it can be very interesting to expand the possibilities of how materials are being used. And the question would be then how we make that happen in reality. But overall, I think it's about, leveraging the potential of these tools as a means of inspiration, but also not taking it for granted that whatever is going to be proposed will be efficient, feasible, possible, stable, all of these things.
I use ChatGPT, again, also almost every day, including the slides I presenting today. So I can see that it's changing my life and changing my work. Well, for robots, I'm a bit hesitant about how the big model can change the way the robots work, especially for the low-level control, sensing, estimation, things like that. I'm a bit hesitant about that part. But one thing I think is very interesting to me is how can the big model can be for example, an agent of a like an operator of the robots, because most of the current robots are still being operated by humans. For example, for drones, for aerial photography drones, like schedule, it can perform the task autonomously, but only a specific scenario. So in most of the applications, still the human pilot is still, operating it, how to obtain a good shoot, like an action movie, things like that. But those kind of work probably can be combined with the big model, because I'm thinking probably we can feed those video clips, aerial photography video clips. We can feed those good clips into the big model and let it to learn what is defined as a good shooting of the aerial photography. Well, it's very hard to model. It's very hard to describe. It's just a feeling. It's a feeling of the of the director of the movie, things like that. Well, probably there is a place where the big model can play a role there. But for the low level safety and security, for example, how to make sure that the drone is still safe in a cluttered environment, well, I still believe the model-based approach probably has a higher chance. Yeah. So that's my two cents.
So to summarize, Fu's ideas for things that we already have a model, let's use the model. For things that we are not yet sure how to model it, maybe we can try AI-based method.
Exactly. If
Thank
we
you.
have the model there, why don't we use it? Like the Newton second law, it has been there for hundreds of years,
Right.
and we have verified it in many engineering fields.
Right.
Why do we give up the more and we start from beginning?
Right.
That's my
And the
thinking.
question and the relevance to this community is, for construction, do we have more models that is known, or do we have more models that are actually unknown to us?
Well, I think
That's an totally open-ended question.
it's open-ended.
Thanks.
Yeah, sure.
Thanks.
So maybe I'll speak from a perspective of a startup, which is that ChatGPT and the AI tools are a kind of force multiplier that allow us to really like double or triple our productivity when used right. And that's what's so funny about these new tools. Maybe it's their immaturity, or maybe this will always be its nature, but I'm not accustomed to having a tool that could lie to me or hallucinate, and that I have to interrogate its answers. But when it's right, it can be brilliant. I can ask it a question. I can even ask it to do work for me, write this code, and boom, I can get code. But half the time, that code is simply incorrect in the sense that it will compile, it will execute, and it will give me the wrong answer. And I have to know what is the right answer. So it doesn't eliminate the human from the process. And there's all this talk about how ChatGPT and AI is going to take over the world and eliminate jobs, and I have no fears of that whatsoever. For me, it's simply an additional tool that I can use that can enhance me when used correctly.
Well, thanks a lot. Let me see. Okay, great. We already have some question from the audience.
Hey, thank you very much. So I wanted to ask something maybe more related to SLAM. So people normally have work on SLAM, like you have data, you pass that data through a front end, for example, that computes registration or matching against the map. Then that gives an output, you register it in the map, and then you go again, like for multiple cycles. But if you think of this as a, I don't know, like a regulator, a control system, it's an open loop system. Have you guys also considered having more like closed loop approaches in SLAM, for example, having validation of matching? For example, if you're matching a wall, checking if there is disagreement or divergence. Because if you're in an environment like in a construction site, this could be really like a value, an insight. Yeah.
Sure, I can go because for me the answer is easy. Of course, that's all the interesting stuff. I would say that all the papers you could read in this very conference are touching on elements of how do we improve correspondence, how do we have a higher level of semantic understanding, and how do we, I think to use your words, close that loop between a priori information and current information, and to develop either stronger matches or to develop as-built differences or kind of change detection.
Well, yeah, that's a changing environment. So that's also the main theme, I think, in this workshop. Yeah, the theme of this workshop. So that reminds me actually a question. So because I see this challenge, well, it's truly challenge. Well, I see the challenge. Well, this year I didn't participate in this challenge because it's so hard for me. I mean, I didn't solve this problem ever before. For the like map accuracy, things like that. And yeah, have a little bit experience. But for this one, well, it's so drastically different. Like the data is connected, like half a year before and register to the current time. Because with half a year, well, the construction site has changed dramatically. Well, I think so that's one type of changing. Another type of changing is like gradual changing. So it's not drastic changing. Like, the robot is operating in a daily life, it operates today and build a map today. Like, but the chair is moved, the desk is moved, the things like that. But those movements is not drastic. Most of the environment is still similar. Well, the second day, the robot starts again, but well, it will find some changes, but most of the majority is still quite similar. I think for a daily life robot, what they changing, I think is gradual changing. Well, for this, I think there are tons of research already there. It's able to like model like occupancy grid mapping, like how can we decide a like a part, a voxel, things like that, a seal that has been occupied but becomes free, things like that. So there are many techniques that can be leveraged. Well, this is also, I think, is a very necessary step for pushing the actual robot to real world, especially as a product to benefit people, because the real environment is really changing, but it doesn't change drastically. Yeah, that's my interpretation up so far. Yeah.
Yeah, I don't have much more to add. So if you want to go to next question or.
Okay, cool. I think. All right, I see that question. Now we'll come back.
Hi, so thanks to this workshop, we have seen that we are all doing a lot of research in terms of robotics and construction, but we don't see the robots in the construction field yet. So what are we missing? Are we missing what's going to be the breakthrough that is going to put the robots in the construction? Are we missing the hardware, the software, the communication with the industry? What do you think is going to be the next challenge that is going to change this?
Since I hold the mic, I can start. I think, thank you for the question, because this would be my pass to the people on the panel who are from industry. So from our side, as roboticists in academia, we like to play with things, experiment. And the question is, what do you think you need from academia to be able to deliver products, or to whatever, use some of these technologies that some of them, we've seen them here today, and there are, I guess, other works as well. So what do you think the industry as a whole needs in order to adopt such systems in reality?
Okay. Hi. And as the end user, we are as a construction company, and we want to more is used the practical as a robotic system instead workers. But actually, we cannot find good solution in the market, because good solution means we can use the robot and we can reach our target to complete some work and to reach the quality, and we can hand over to the client. This is the same process as the traditional construction process. And then that means we replaced one worker. Today is one robot. Robot is need to same things by the worker, but still we have no we cannot find the robot system in the market. That means I think many is the academic part is developed the technology, and some the company is assembled sees the technology, and they make some the new is a robotic system. But the system, robotic system is still is a very early stage the solution. And then for us, we want to make the planning. Planning means how many is a robot we can use, and how we can complete the work with the robot in the our timeline. And we set the milestone, and we provide to the subcontractor to our the site condition, and also we provide materials to the subcon. This whole process need to make the own the planning. But maybe some robot is bring here. We cannot we do not is confidence the robot can fix the puzzle to in the whole is a process, and we cannot use the robot system. That's very natural. And then as for my the personal the experience, we need more make the market to more the academic part and startup companies to more make the profit, and also the construction site to more easy to find the solution in the market. But still the construction, the robotics market is not there. From my understanding, there is no the actual market. And actual market means the logistics, and then the stakeholders, and the training and the education is all things is included. And then first is we need to make the industry the formation to more deploy the robotic system in actual site. That's my the opinion.
Thank you for your question. As we know, for me as a civil engineer, I know the construction is need many procedure. Yeah, it can't just be one kind of procedure can finish all the buildings. So maybe thousands of more than kind of workers, different workers to finish. So for the robots, there's a question: can one robot do all the work? Yes, the answer is no. So maybe in one procedure or one task, the robot can do better than human. But maybe if we want to do other work, they can't do that. But when humans as a worker, he can adjust his work to that job. So I think maybe in the future is we want to create a system, a construction system, quite new with only simple task. So that can be suitable for the robots. But as for now, I think the robots may be most useful in some special construction sites, like the remote area, such as underground or deep ocean, or even lunar base. Yeah, that's my answer. Thank you.
Thanks. For me, it's not an easy question. Probably for all of us, right? There's not like a single holy grail that's holding back the industry. If we look at construction as a whole, it's driven by many of the same product motives of other categories. It needs to be faster, it needs to be cheaper, and it needs to be better. And if a robotic solution can achieve one of those three, then it will start to compete against the conventional system. But that's where we struggle with robotics, right? Like I think many of us here are coming from the bottom up, if that's the right analogy, where we're developing this technology and we're trying to bring it up to that level. So is it faster? Robots now are not really faster on a construction site than a human. But that doesn't mean that can't change. If we look at how robotics have been applied in manufacturing, robots are vastly faster than people. So we know the potential is there. It's just the environment and the challenges are technically more challenging. Cheaper. Robots are not cheap. They are significantly more expensive than people in almost every single market. There are these exceptions where you simply can't have people on the moon or remote locations or in nuclear sites. So that's an entry point, like a nice niche. And then ideally, if we follow the regular manufacturing process, the more we make, the cheaper it gets. But again, there's lots of examples of overcoming this. If we look back at automotives in the earliest 20th century, cars were also very expensive. And the market went in two ways. Ford made a cheaper car that people could afford. GMC invented financing that allowed people to be able to purchase that. And I think both of those options are ways to get a robot to market as we invent newer ways to solve the, say, a robotic arm problem, which is a common one that comes up. And we already saw some examples today of some innovations in that space. But then we can also move away from the idea of companies purchasing robots. They can simply lease them, and that becomes a whole other mode of bringing robots onto a site. And then finally, better. Can a robot do something better than a human? Today, sometimes, not always. I'm reminded of my past role where we at Hilti, where we have a robot that will drill holes overhead. And over enough time, it will outperform the speed of a person. But is it better? It's such a funny thing because a very common problem you have when drilling holes on a construction site is you can hit rebar. And for a person, they know instantly when you hit rebar because the whole thing will shake. And the solution is, eh. And we've been working years for the robot to figure out to go, eh. And so it's these kind of practical problems that we encounter with robotics that that humans are so perfectly adapted to solving that robots are just really stuck on. So lots of opportunities to break through, but we're still building up there.
Thank you.
All right. Any? Okay. So.
Yeah, thanks. I have a bit of a difficult question. I would like to talk about the adoption problem. So really nice lead in. In academia, what we look at as measurement is root mean square error, precision, recall, and that's what we're actually pursuing. So the better method is the one that had better precision, better recall. However, in the industry, what we actually look at as the bridge between the algorithms and applications is slightly different metrics. So metrics like initialization. Will it initialize 100% of the time? If it doesn't, we're not using it, basically. Then stability, robustness, the typical things. But one of the metrics that I've never heard mentioned in academia is cost of failure. So when the method fails, and we know it fails because it doesn't have 100% performance rating, what happens? So what are your thoughts of that cost of failure? I'm not saying that's the holy grail, but how do you think that we could link that or take that in account while developing algorithms systems on an academic level?
Well, that's reminds me, the difficult of the translation between research and products. For research, as a researcher, we definitely have to concern with publications, things like that. Novelty, well, because we're criticized by the reviewer for that. So, but my feeling is, research product can barely be used as a actual product for the industry. There is a gap. The gap has to be filled by a very excellent engineering team. So, like you mentioned, the initialization problems, things like that. I'm pretty 100% sure there is definitely an approach for solving those problems, but solving those problems may not be interested by academias. Well, why? Because it's just a power of engineering, a power of if else, things like that. Well, in very rare cases, we are able to extract a certain, a significant research problem out of it. But most of them, those are just engineering. So for engineering, students or even, professors or researchers are reluctant to invest. Different situations. So my feeling is, the academia, the research products is just a proof of a concept. Well, in many cases, well, probably in very few cases, it works very well. Give a very good video. Wow, so eye-catching, results. Wow, so excellent. But in the product, wow, it failed again. Well, so I think there is a gap. So we have to form, there must be some people dedicated in solving and embracing this research to the real products. But I'm pretty sure their approach already is there in some literature, some paper, or even though they're not. Well, that's probably that's a place the industry and the academia should collaborate with those fundamental problems. But so I just mentioned that the most difficult, the challenge for my research career is how can we identify interesting research problems. So that's what I mean actually, because if you want to identify real interesting problems from real industry, you have to go into the industry. Otherwise, you just think of the problem from the papers. You read the paper, I have an idea, I implement it, I test it, I run the data set, it achieves good results, then done. But in reality, it probably may not work so well. But you have to go to the industry, you have to apply you have to go there, talk to the people. That's a difficult part. Yeah. Sorry.
I don't, you covered me. There's another question.
I think everyone has been thinking about this, and I think it's a little bit light brush to say that it's just engineering problem. I think there's something else, which by myself, I don't have the answer. But what I want to share is that I don't think it's just engineering problems, right? So if that's just engineering problem, everyone can take textbook that says your solution requires A, B, C, D. Here's the textbook tells you A, B, C, D. Everyone can engineer it. So there's something else. Very often when it comes to reality, we say it's just engineering integration. It's not. Very often we get 90% done and 10% we have no clue how to do it. There's no theory, there's nothing exists that help us solve the problem. That actually is here, the shortest bar that prevents us from doing it. So I would say that it's not very honest answer or responsible. No complaint here, but just honest answer from my side is that I think both sides deny to admit the reality is that there's something missing there we don't know from both communities. And once we solve that, everyone can take that GitHub code, problem solved.
Yep, I agree with you. Well, eventually it's not engineering problem. There could be some fundamental research problem and very interesting one. Well, this comes to another reality because different researchers often have a specific scope of research. You know, they cannot solve all the problem because it's the efforts of the community as a whole. So, for example, I use like UNO every day, but I never research the deep learning method. I just treat UNO as a tool. I just borrow it and I use it. If UNO cannot do it, yeah, I don't do it too. That's the best I can do because I just directly use it. So my point is, you know, every researcher has this dedicated specific scope of research. Beyond that scope, you know, it's probably should be solved as a different areas, different teams as a joint effort. But that's not easy again, because so you know, research, you know, is you have to manipulate many resources solving actual problems. So it's not engineering problem, but it could be beyond the research scope of a certain researcher. But the other researcher who are suitable to solve them may not be aware of this fact. So there is some information gap. Sure.
I think what I want to say is related to all three questions. I definitely agree with my colleague here that we need to consider our role in academia, and the role is usually about tackling the fundamental problems. And then on the other hand, we have the industry, right, that they're looking to academia to get some solutions out. So obviously construction side, use of robotics in construction side means that we're still not there yet. That's why we have this workshop, right? And we're discussing a lot of research ideas. So I think there's this gap that we can call it the engineering gap. Some of it is engineering, some of it is addressing fundamental problems. And I think in order for this knowledge transfer to happen and bridge this gap of engineering and fundamental problems, then we need to start talking to each other more, because we really speak two different languages. We are very interested in fundamental problems, whereas the colleagues from industry are very interested with results, numbers. Can you give us this robustness? Can you give us millimeter precision? Can you give us centimeter precision? And can you give us 100 times initialization? And I would say that robotics is pretty unique in this sense, that it's probably for the first time that people are starting to think that these questions are, maybe it is difficult to initialize 100 times, right? So when I went to pitch my most recent project, I said, I want to do all of that at the push of a button. And I think that's very cool, but I think that's very difficult to make it happen, right? So yes, there are some fundamental problems there, and there is some engineering work that needs to happen. But if we start talking to each other and hopefully having joint projects, then that means that we can start to learn your language and you can start to learn our language. And to be honest, Hilti has done a brilliant work in this respect. So we have had a very open relationship in terms of an open-minded partner for research that would give us access to the problems of the construction side and access to the actual construction side to run experiments.
Well, I have one last comment. Well, I think the industry is asking the problem. That proves that, you know, the system is probably almost there, but there's just one last step we have not accomplished. But that is still a good signal. That means, you know, that doesn't like, you know, like a decades ago, really people, not so many people are interested in robots, so expensive, so, you know, limited in capability. But now I can see more and more people from industry, students that get more interested in robots. And also AI, applying the AI technique to robots. Well, I think, you know, it's still, you know, a very good signal for the whole community. Yeah.
But what I heard in your question was almost a kind of product manager discussion, because we're discussing robotics technologies, but what is the solution to my problem? If I want to build this wall, it's great that I have a robot, but how do I purchase it? How do I get it here? How do I maintain it? How do I make sure that it's working? How do I maintain it? It's safe. That's the product solution. And I would say that is an industry question. I mean, that's literally what industry does. We take the innovations and we turn that into a product. And yeah, industry is still kind of at the beginning stages of being able to answer all those questions reliably. You know, we've got a couple of examples here. Hilti has a little bit of experience there too, but we're still working it out because the problems that you encounter with a robot on site are very different than other kinds of tools. And so the back end, the whole procurement supply chain is so different when it comes to robots. You know, if I have a problem with my hammer, I go and buy another hammer. If I have a problem with my robot arm, I place an order and 6 months later, maybe it ships. You know, this is the kind of challenges when it comes to delivering a real working robotic solution. So I think your comment was, what's the missing 10%? I think it's bigger than 10, honestly, when you want a reliable solution set of different robotic solutions.
Yep. Well, I think we'll have time for one last round of discussion. And I think we have a question from there. So.
Okay, thank you. As we already discussed, ChatGPT is a very useful, very powerful, but it's a large language model. So should we expect a large robot model, or at least a large construction robot model? And do you think it's necessary? Yeah, that's my question.
I think it's quite what different researchers have different opinions. Well, for my opinion is on the data level, I believe there is a large model for specific fields, like large construction model on the data level. But on the physical level, actual robots, I am a bit reluctant to say so. I think it's the actual robots working in the environment. Well, there are many good things we can leverage the large model, but probably it cannot do all the tasks, especially on the physical level, interaction between the robots and the environment, avoid conditions, things like that. Well, I think, you know, a mixture of learning and model-based approach is likely the future. Yeah, it's my 2 cents. Yeah.
Okay, as a model for the robotics, before that we think about how we can produce the model for the planning of the construction at the project before we start the project. Because currently the project planning is based on the experience of the engineer, and we can see exactly what happened in the project, and that is very important. We have think of the many the risk and how we can control the project. And then the robot part is one of that is the whole is models the piece with things, and we are now trying to make the project the planning model read always the historic is data. And then we can is the edit the robotic model as in the is the always pool modeling. But still we have no is the enough the data of the robot the working in actual side. And then we are now is the also working to is gathering the some the model of the robot. But the problem is the model, the robot is itself is the developed by the many is kind of the language and many kind of the technology, many persons the logics. And then at first we are now is the start my work is standardization of the whole is the robot is control system. That is our current situation.
Thank you. That's an interesting question. I think in our area, we have a name called digital twins. It means one is the physical model, another is the visual model. We want to combine them. So we, for the robots and the AI and another like scanning robots, we want to we actually want to combine them because if we put them together, we can make the data connection and we can make it more communicate more fluently. But for now, for now is not what we expect. Yeah, not that I know. So I think I hope someday we can make it come true with the hope of robots experts and our civil engineers. So yeah, that's my answer. Thank you.
Great. Thank you. Well, I think we're approaching the end of our workshop today, and in the panel we have some very interesting and discussion about the relationship between academia and industry, and then how this whole AI thing is influencing our field and other related field. I think all these are, we should continue the discussion and end the panel at this moment. And yeah, if you have additional questions for the panelists, I would suggest you stick around and interact with them afterwards. And yeah, I think that's it. Thanks everybody for participating. And let's give our wonderful panelists for last round of applause.